In this lesson, we're going to cover the structure of an IPv4 address. Now, most commonly, you can see your IP address by running the ipconfig command. And what you'll see is your IPv4 address. And in my case, it's 192.168.1.134. What this address actually is a 32-bit address. And what you're seeing is this address written in what's known as the dotted quad format, or 4 8-bit numbers. For example, 192, if I type this in my calculator in programmer mode, you can see is actually 11000000. So in reality, what's actually happening is each of these numbers is a binary. That's how it's actually being stored. But for ease of reading, it would be very hard for us, for example, to read an IP address of 1100000010101000000001, etc. And so this dotted quad format makes it very easy for us to understand and use that IP address. And this IP address is actually set and configured through the IP stack of the operating system. So each adapter in your machine, it can have an IP address. Now, this is not necessarily the case. If I look at my adapter settings, I look at my network adapter, you choose which basically protocols and functionality is linked to each network adapter. So for example here, IPv4 is connected to this adapter, and then I have my properties. In this case, it's set to obtain an IP address automatically, which means it's getting this from a dynamic host configuration protocol server, or DHCP. Now, you can have multiple network adapters in your machine. Certainly most servers do have multiple network adapters. So each of those network adapters would have its own IP address. And indeed, it's even possible for a single network adapter to have multiple IP addresses. So I have an IP address, and it's written in this dotted quad format. However, in reality, machines can't actually talk using just the IP address. For example, I have to actually know, well, which machine actually has that IP address. An IP address is something I manually set or is configured through a protocol such as DHCP, but it's not a hard link to a machine. I need something that's unique to that machine to be able to find out, well, who is IP address, whoever I want to talk to. So each machine also has something called a MAC address, Immediate Access Control. And I can see this if I look at my machine and do ipconfig/all. One of the things it shows me is my machine's MAC address. So this is the physical address, so 00155D013903. Now these are hard set at the time this network adapter is actually fabricated. So this is set by the manufacturer of the network adapter. Now virtual machines also have MAC addresses. However, in reality, this is mapped and translated to the physical network adapter of the actual host itself. So these are really not seen outside the physical machine. So this is actually a 48-bit address, but this time it's written as 6 8-bit numbers in hexadecimal, hence the 5D, for example. If I was to go into a hexadecimal mode, and I'll clear this and I type in 5D, what that actually relates to in decimal is 93, or in binary, 1011101. So each of these is actually an 8-bit number. And so when two machines that are both using TCP/IP wish to communicate, the first thing they actually have to do is work out, well, who am I actually talking to? What is the MAC address of that machine I wish to communicate with? The example I always use is thinking about delivering a letter to a house. So if the IP address would kind of be the equivalent of the street address, 13 Baker Street. The MAC address would be, for example, the GPS location, the physical plot of that house in the city maps. If I wish to deliver a letter, well, I need to know where that house actually is. So I could look at a map, I could look up GPS coordinates, whatever. But I need a way to actually translate that. And so in the IP world, that's called the Address Resolution Protocol. So when I as a machine need to actually communicate to another server using TCP/IP, I use the Address Resolution Protocol to find that machine. So as an example here, let's go back to my command prompt. And I'll clear this. I can do ARP-A. So this is actually showing me all the translations I have in my cache for the various TCP/IP addresses I wish to communicate with. So if I clear this cache, and then what we're going to do is actually start a network trace on a machine. Now you're going to see lots of traffic. So if I look at my cache again, actually, There's a few addresses because things are going on in the background. Now if I try and ping, I'll ping this server. So that worked. But what I'll see is in the cache, I now have the MAC address of that machine I tried to talk to. So before it actually pinged that machine or tried to communicate, the first thing it did was send out a broadcast over the network to say, who is 192.168.1.10? Please send me back your MAC address. So this is the address resolution protocol giving me that information. If I go back to my network trace and stop this, I can say, show me all the ARP type traffic. Now, obviously, there's lots going on in the background all of the time. But what I'll actually see is, for example, here's a request. So 114 is asking for who is 192.168.1.10. You see, they actually sent an ARP request. And the request says, here's who I am. Here is my MAC address. Here is my IP address. I'm looking for 192.168.1.10. I don't know the MAC address. So it's all zeros. And then that machine sent a response back. So this was a broadcast sent over the entire network. This was sent to everyone on the network. This is then a response. And the response is actually telling it, okay, here is my MAC address for my IP address. So now that sender, the one who wanted to try and communicate with that machine, now knows the MAC address, and now they can communicate using that MAC address information. This is all taken care of for automatically. You don't manually have to do this. But it's important to understand, under the covers, TCP/IP actually is translated into a MAC address, a physical address for that machine, so they can then communicate. But again, you never set those MAC addresses. This is something set by the network fabricator. What you are concerned about is the IP address of the machines you're setting. So again, ipconfig is a great command. I can go and see my address, my information. You can set that manually, and we'll cover that in a future module. But essentially, an IP address is a 32-bit number written in this dotted quad format that when we communicate translates to a MAC address that's done automatically through the ARP protocol.